You may please put your attendance. I'll be sharing my screen and we'll be discussing what content we have already covered and what are the new things we are supposed to discuss today. Okay, so possibly you remember we were talking about classification of emulsion. That part we have already done. What are the different class of emulsion we could have? I think my voice is audible, right? So we talked about what are the different kinds of emulsion. We can formulate oil in water and water in oil, emulsion types. And we need to have some surface active agents which will actually stabilize the emulsion. So we'll discuss on that today. Basically, different kinds of emulsifying agents we might likely to use. So I'll talk on them. You may definitely check from your textbook. This textbook, I'm also highlighting some of them. And I'm coming to one presentations which will be relevant for this discussion. Just come to the point. So in your exam, up to this emulsion, we will be considering for your second internal, because if you remember, we started discussing particularly from your first internal perspective, it was until tablets, right? Different kinds of tablet formulation we discussed. Subsequently, we had a discussion in this class related to the capsules, hard gelatin capsules, soft gelatin capsules, preparation, what are the ingredients, all those things we discussed, right? Someone is trying to join. Who's King Raj? I don't know. So basically, we are going to, then we came into a chapter where we were discussing about primarily on parenterals, right? So parenteral formulation we discussed. So today, and then we started discussing on emulsion. So three different chapters will be considered for your second internal questions. So please be cautious on that. You may please go through the textbook primarily. Now, today we'll be talking about the different kinds of emulsifier. Basically, I need to tell here what are the primary emulsifier normally used. Emulsifier, you already know. The basic structure of emulsifier is a molecule which will have some hydrophobic chain, and one group of hydrophilic. Hydrophilic can be hydroxyl, carboxylic group. These things should be there preferentially. These functional groups will be there in a single molecule. So that is basically, this is for lipid part or lipid loving part, and this is hydrophilic part, water loving. And essentially there are three different class of emulsion, three different class of emulsifier can be considered for pharmaceutical preparation. One of them is known as anionic. Other one, of course, if you know anionic, then it will be another one is cationic. Another is non-ionic. These are based primarily, this classification is based on what is the charge. Is it positively charged of the molecule at neutral pH? Because charge is going to change. So anionic groups will be primarily dealing with, for example, you know, one of any example of anionic surfactant in your lab you might have used? Yes, we know. That is sodium dodecyl sulfate, SDS. It is actually negatively charged, right? Sulfate, sodium dodecyl sulfate. So sodium is the salt, dodecyl is the long chain length of the polymer backbone, and sulfate functionalites are also there, so it will make it the hydrophilic group. So SDS can be one of the example of anionic surfactant we normally use. We also have cationic surfactant, probably you know, because we are biology people's biology students, you have already probably used in your lab. In as far my knowledge goes, if you have done the molecular biology lab, there was isolation step for DNA and cell disruption process are there. In that case, we normally use either SDS or CTAB. So this is anionic, this is cationic. And the third group, which is more widely used, this is actually more preferred. There is a reason for that. That is like Triton X100, sorbitan molybdenate, Triton X100. These do not have any charge. Okay, so these are neutral molecules. Now, when we are using those surface active agent or surfactant molecules in any formulations, you need to understand that these cationic groups are known to be little bit toxic. They are positively charged. They are toxic for us, for individual, for consumption. If I am taking it, some emulsion you are taking inside, so like oral doses form, these cationics are too toxic. Anionics are moderately toxic. It still can be used. And non-ionics are okay. Non-ionic surfactants are more easily used, and there is two particular groups are there, span and twin. So probably you will heard the names of twin 20, twin 80. These are the surfactant we have used multiple times for emulsion preparation. So span, twin are non-ionic group. Cationic group is CTAB, cetyl trimethyl ammonium bromide. So ammonium group is the positively charged functionalites. SDA, sodium dodecyl sulfate is the anionic. Example I'm talking about, not necessarily this is the only surfactant we can deal with. And here Triton X100, twin 20, twin 80, these are all non-ionic group of surfactant. What I understand, anionics are okay, cationics are very dangerous, toxic. Cationic groups are toxic. Anionics is moderately toxic, and non-ionics are safer. This is one aspect we should always consider when we are preparing any emulsion. Another aspect is that the anionic or cationic surfactant, for example, I am saying this is a cationic surfactant or anionic surfactant. If I am taking inside some emulsion, I am preparing with those, for example, cationic surfactant. And the emulsion, when you are ingesting, it is going into your stomach. Now, what will happen? If there is a cation, anything is going to be ionized or non-ionized, you need to understand that the charge of the molecule will depending on pH. Okay, so what does it mean? We are having a molecule, and if I change the environment, so it will be charge will actually going to be reversed. For example, let me talk about, I'm having one molecule, I'm just giving a nomenclature like RH. Some hydrogen, ionizable hydrogen is there, which normally can ionize into R plus and H minus, that is, I'm sorry, H plus and R minus. For example, this is the normal ionization would happen. Okay, in other way. Now question comes, if there is high amount of hydrogen plus ion is already there in your media, it is too much, I mean to say the environment is little bit acidic, then these things will not happen. The ionization will not happen. This side it will not go, and it will be simply non-ionized, or unionized form will be higher. So basically what I am trying to say, if I am having some negatively charged groups and I am going to utilize negatively charged group is this one, and we are going to have very acidic environment, so they will actually cause formation of this. This will not be available. This will be all abolished. It will form this. So your surfactant is going to change. Okay. Earlier it was a surfactant, but when I am going, these ionization groups are lost. It can no longer act as a surface active agent. So pH of the intestine, pH of the application area is very important regulator for cationic and anionic surfactant. For both of them, this is the story. For anionic, the opposite picture will come. Anionics may be something I'm telling that it normally behaves like this, R plus and OH minus, for example. So R plus is the cationic group and OH is the negative ion. Normally it happens. But if there is too much of hydroxyl ion, just for simple assumption, in the media there is too much of hydroxyl ion, I mean to say this is a basic environment, that time this ionization will not happen. So this is not allowed. So it will go this side. That means it will become unionized form. So in basic environment, if I am having some cationic surfactant, that stability will be lost. It will become this. So this you need to understand what kind of surfactant I am going to use, what is the pH. So pH is going to control the ionization and stability for both cationic surfactant and anionic surfactants are really important. So pH of the media is important. So most of the time, those surfactants are not used for preparation of emulsion, which you will consume, because the emulsion will go into your stomach. It will make acidic. Then it will go into large intestine, which it can turn into a basic. So acidic environment, basic environment will cause those kinds of surfactant to become unstable. So initially they formed a emulsion, no issue. But when this thing is either ionized, part is gone, they're becoming neutral charge, then the emulsion will automatically break. They cannot work. So emulsion stability in your intestine or stomach can be compromised if I'm going to use some cationic or anionic surfactant species. That is very important. We normally use those emulsions over skin applications, right? Skin is fine, even if there is a little bit toxicity, not a big issue, but we cannot consume it. So that is the only one part I wanted to highlight in this aspect. Second thing, what is we are going to talk, then okay, in our last class we talked about HLB system, hydrophilic lipophilic balance. What kind of surfactant we should use? Use to prepare an I mean to say emulsion. This question is very important for you. This is very usually very important for any pharmaceutical preparation who is going to prepare. Let me talk about HLB. HLB is actually nothing but it's simply a scale we are putting for each of the surfactant, and we need to know what is our desired property. Let me come to the very simple point. For example, we are having some soybean oil. Very simple questions. And water. I want to prepare emulsion of this. Now, first question is that what is your oil? Is soybean oil. Now, we already have a table. People have already created a table that what is the requirement of soybean oil, what kind of emulsifier it is looks, or I'll simply say what is the required HLB of this oil to form a emulsion. So that means what I am my question? My question is that, okay, we are going to prepare soybean oil and water emulsion. So from this analysis today, what I am going to discuss, you should be able to tell that, sir, I will mix this surfactant and this surfactant, and I will going to prepare the emulsion. That is the normal thing we are coming to at the summary of this analysis. Now, question is that we are going to have a soybean oil and water emulsion. First question is that what kind of emulsion you are going to prepare? This is the first question you should ask, because you may prepare oil in water emulsion also or water in oil emulsion also, but both are not same definitely. So for soybean oil to be part of any emulsion, it has a required HLB value, required. We will get it from literature. Of course, how literature is getting, that is a different questions. I will come to that point later on. So for example, it require a HLB. Okay, what is HLB value? I already told HLB is the balance. What is the likeliness? What is the likeliness of any surface active agent, any molecule in between two phases? There is, for example, there is oil phase and there is water phase. What is the tendency of your emulsifier to go this side or to be this side? So balance between water phase and oil phase. So each surface active agent, each surfactant has a HLB value. First of all, HLB values are there for each surfactant or emulsifier, whatever you will say. They have a values. Each of the surfactant has a HLB values. HLB values run between, we have scaled them in between 1 to 20. So 20 is the maximum value, 1 is the lowest value. This is a scale, like pH, we are having a scale, same kind of scale. Now, if I am saying that, okay, we are having one surfactant twin 80 or span 80 or SDS, each of them has a HLB value depending on whether they are more likely to be oil-like or they are likely to be in water phase. So there is a scale for each surfactant, there is a HLB values. So for example, for this I am having HLB value of 4.5, for example, and another surfactant B is there. For example, its HLB value is 13. So these are the surfactant HLB values are there. What I was talking here is not about surfactant. I am talking about a oil which will, what HLB does it requirement to produce oil in water or water in oil emulsion. Let me come to the very basic things. So as I started with soybean oil, it can produce two kind of emulsion, if it is producing oil in water emulsion or water in oil emulsion. It has a requirement. Okay, so when it is producing water and oil emulsion, water in oil emulsion, so for example, we require a HLB. This is required HLB. For oil in water, we also have a required HLB values. Let me take more things on this, that okay, HLB value is for example 15, here HLB value is for example 6. What I am telling? I am telling that soybean oil emulsion preparation, if I am going to go for oil in water or water in oil, they have two different HLB requirement. One is 15, another is 6. Now, this we are already providing from literature, or data is already there. Now question comes, I am having two emulsifier. One is A emulsifier, another is B emulsifier. And I am telling that, okay, I will use 5 gram of the emulsifier I want to use in 100 ml of or 100 gram of oil and some amount of water. Now, what kind of emulsion you are looking for? So I am asking, or maybe you are assuming that, okay, we are looking for oil in water emulsion. And I am having two emulsifiers. These are emulsifier I am talking. There is two types, A and B. Its HLB value is given. For example, this is HLB value is 18 and this HLB value is 6. Just for example. Now I am asking you, I want to use both the emulsifier and I want to prepare soybean oil in water emulsion. I want to prepare. What does it mean? That means I need a required composite HLB value of 15 and my surfactants are 18 and 6. So my question is that at what ratio I should use A and B, two different surfactant. For example, SDS and Tritonex 100. What ratio I should mix? Question is very simple. So for example, I am assuming that, okay, I will use X fraction of this. So 1 minus X fraction of this I will use for B. And compositely, HLB value is always additive. So what does it mean? The composite HLB should fit the required HLB. So this is the target. This is our target because I want to prepare soybean oil in water emulsion. The required target is 15. I am giving you two emulsifier A and B with their corresponding HLB value of the emulsifier. A is 18, B is 6. You understand? 18 means it likes more water. B oil, it is oil loving. So for example, water loving emulsifier can be like as we already know, water loving emulsifier can be phosphate, group functionalites. Oil loving can be oleate, monosodium oleate can be one of the emulsifier for oil loving. So someone is water loving, someone is oil loving. I want to mix them in a blend so that it will give us this. So how to do that? Very simple. So 18 into X, for example, plus 6 into 1 minus X fraction should give us 15. So this is a simple mathematical calculation. Normally people will do plus 6 minus 6x equal to 15. So I can 12x equal to 9. So x equal to 9 by 12. So 0.75. So 1 minus x equal to 0.25. So what does it mean? So 75% I will take emulsifier A and 25% I will take emulsifier B. I will mix them together. So for example, I need 5 gram of emulsifier. So I will take A equal to 75% of 5 gram. I will take B 25% of 5 gram. So I will mix this together. So this is basically how much gram is coming, how much gram is coming. I will mix them together and this will be the emulsifier for preparation of the emulsion. So this is very important because when you are going to prepare any emulsion formulation, to make it useful for or make it stable, we need to have those calculations. So HLB you need to understand, it is a balance between hydrophilicity and lipophilicity. Second thing what I talked today is that sometime we may need to use more than one emulsifier. Mixture of one or two emulsifier I can also use, not a single emulsifier. how should I blend them, how should I use them, that is definitely be guided by what is your required HLB. You see, soybean oil, if I am preparing oil in water, I am using this. Okay, but if I am using soybean oil, I want to prepare water in oil emulsion, then my requirement of HLB is just 6. That means that time I only use B. I need not use A at all. So I can simply no need to use. I can use only B. Okay. If I use A, I can never prepare any water in oil emulsion, for example, because its HLB is 18 and I need 6. So I cannot do that. So you need to understand how can I select one emulsifier for preparation of the emulsion in practice. So these are the basic 2 things we wanted to have. I will go to the textbook portion also for some small discussion. You see what are the different kinds of emulsifier normally people are using. Anionics, you go through this book also. That is sodium lauryl sulfate. We very significant amount we normally use, and SDS is used primarily for oil in water emulsion, because SDS is moderately, it makes emulsion, but it loves more water phase. So it will prepare oil in water emulsion. Similarly, if I am using some oleate group, oleic acid salt, then it will produce the opposite one, water in oil emulsion. So it likes more oil. These are most widely used in topical application. Why? Because I told you these anionic surfactant or cationic surfactants are actually toxic. Cationic surfactant can be quaternary ammonium compound like cetrimide. Cetrimide is used, that is a topical emulsion, and it produces oil in water. You see what is there? A long chain fatty acid. You see C12H25. That means a chain, hydrophilic network of chain, long chain. Here C16H33. You understand? It is a alkyl chain. And then at the end, I am having some functional group. So positively charged N plus is there. When I'm having alkyl sulfate, sodium lauryl sulfate, you see negative charge is there, SO3 minus. Here, sodium stearate, acetic acid group, acidic group, COO minus. So these are actually, it will go ionized, right? COO minus. So this is the hydrophilic part. This is the they are not showing any structure here, but anyway, you understand that there must be some positive group, must be some negative group for anionic and cationic surfactant. They may produce oil in water or water in oil preparation, but mostly they are using for topical preparation. Topical means on the skin surface. Normally do not take it. But some cases, if it is non-ionics are a little bit less toxic. They are preferably used, as I was telling, sorbitan monooleate, that is span 80, similarly twin 80, okay, polyoxyethylene group sorbitan monooleate. These are actually non-ionic, they are not charged. They can be used for topical as well as in some cases parenteral. Parenteral because they are non-ionic and they are less toxic, they can still be used. So these are the cationic, anionic, non-ionics are there. Polymeric surfactants are used, but they are not so widely used. The reason is that they are really, these are not general chemicals, but synthesized in lab, and many times they are patented products many of the times. So sometimes they cannot be utilized in global scale, or maybe overall use of those products are not very high. And most of the time emulsion we prepare for topical use, and these are well suited for that. Okay. Emulsifying some natural origins are also used. Natural means we are all talking about chemicals, but we also use some of the natural agents like gum from plant origins. Okay, you should see polysaccharide, we can use methyl cellulose, acacia. These are all derived from natural origins. Okay. Lecithin is also phospholipid, as I told you. It is a very good emulsifier, and we can get it from eggs. So these can also be prepared for oral use because they are more safe and they are non-toxic to us. So some of the example you can just keep in mind. Why you cannot use the ionic one? Because they can be irritant, they can be causing discomfort in gastrointestinal tract. So anionic is always good. So cationic, anionic, I already talked. So you can see there is always a long chain of carbon followed by some sulfate group. They're preferably used for oil in water type of emulsion like sodium rhodocyl SDS kind of things. They can be widely used. Monovalent salt, like here you see we are using acidic groups, okay, long chain fatty acids we are using. Triethylenolamine can be used, monooleate esters can be utilized in this case, and non-ionic surfactants can be more widely used, particularly those span and twin groups. Polyoxyethylene groups are used, right? So they can be all useful for preparation of emulsion. Anyway, you need not go through all the example here. Okay, then we are coming into phospholipid lecithin, is fine. Then we are talking about HLB values. What is the HLB we need for preparation of any emulsion? What HLB is the requirement? Normally we are having some scale 0 to 20, but we can also have some cases, some ionic surfactant can have much higher values, but we do not really consider all of them. So HLB is a lipophilic, hydrophilic, this balance things, and you can see some example of HLB values of some of them. Okay, here some of these things, as I told you, some groups can be very high HLB values. Otherwise, normally ionic groups will have very high. Otherwise, they are moderately in between 1 to 20. So this HLB scale is not very strict and rigid. Just for example, we are talking. So here span 18, span 80, span 60, span 20, breeze 98, twin. Twin is very widely used in our labs also. We normally use polysorbate, polyoxyethylene. Okay, so polyoxyethylene is the functional groups for your positively charged. Sorbate and monostearate, monooleate. Oleate and stearate groups are oleic acid and stearic acid groups, and they can be giving you high HLB's values for 14.9 to 15. So you see, these are very high HLB groups of surfactant. In the other hand, when I'm using span 18, span 85, HLB values are comparatively low. So you understand, we are having two groups and we are going to prepare some emulsion. We know that this is the required HLB. So I can find out how can we blend it. We already told you. So how can we make some emulsion? So you see, and what are the different kinds of oil we normally use? Most of the time in our pharmaceutical preparation, we use castor oil, is the one of the primarily used. Okay, but apart from the castor oil also sunflower oil can be used, cottonseed oils can be used. These are the widely used oil phase when we are going to prepare some of the HLB. You see how they are calculating HLB. I have shown you one example of that. HLB phase inversion temperature, that I am not going to talk about that. And next is the creams. Creams are not different. These are also as emulsion only, but sometimes the cream can or may not use both the phase. They can be single phase cream is also possible. Single phase means either oily phase or water phase, but most of the time this is also a thick emulsion formulation. So it is actually oily cream. If I'm going to use, then it can be semi-solid water in oil emulsion, oily cream. But we can also have oil-free aqueous extract can be there, or primarily the opposite one, oil in water emulsion formulation, thickened emulsion formulation, semi-solid, that can also be used as cream. So cream and emulsion are not so distinct. They are mostly in a similar manner, but maybe thickness or maybe the viscosity of the solution is moderately increased. They also need some emulsifier. Okay, so you can just go through some of the emulsifying agents what we are normally using when we are going for emulsifying preparation. Then I will come not these aspects. These aspects are not really relevant. These are physical aspects for emulsifier. Go through. The surfactant we are talking about, natural macromolecules, phospholipid, all those things we are talking. emulsifier selection based on the HLB values, calculation of calculation of the HLB values. Okay, we are talking about the calculation, how what fraction we should use. Then we are having creams, but anyway, creams are not really going to be different. I'll talk them little bit later, not now. And then we are coming into emulsifier properties. This is a really very important property. How can I do whether emulsifier is going to work or not? There are some tests. Testing emulsion. There are many tests. First of all, what kind of question will come to you for emulsifier testing? Many tests will come. First one is the identification of emulsion type. Very important, this test. What I am talking here is, let me, don't read this text here. Let me discuss first. So for example, you are provided with one emulsion, or you have prepared one emulsion. But how do you know whether it is oil in water or water in oil? This is very, very important questions. How can I identify? Or if I ask this question in this forum, rather than I'm going into text, can you suggest that I am having one emulsion? How can I see that? Or I'm having a bottle of emulsion and you need to identify, okay, this is emulsion I am having. You have to identify whether it is oil in water or water in oil. If I ask this question, simply seeing, you cannot do that. What possibility you can have? Very simple things. If I ask you, you put something on your hand and rub it. If you feel the oily texture, simple way, then I understand that the emulsion is actually this type. If the outer phase, after applying on the hand, and if I rub it up, and if I still feel the oily texture, that means oil phase is outside. This is one simple way, but that way normally we will not do, right? We need to have some test. What is the simple test? Let me talk about, okay, I am putting some colored dye. That is called dye test. So if I am having an emulsion and if I put a drop of some oil-loving ink, and whole emulsion is taking the color, okay, whole emulsion is changing the color, and my dye is oil soluble. For example, I am using a colored dye which is oil soluble. There are many in our lab also. And now if I am putting this dye into this emulsion and just stirring it a little bit, and I see, for example, dye color was very violet color, for example. And after adding this, my emulsion is also turning violet. Whole emulsion looks violet. What does it mean? It means that the dye has gone into the outer phase. Dye will normally, the color will come from the dye if it is in outer phase. And I told my dye is oil soluble. That means my outer phase is oil soluble. So my emulsion is O type. Am I clear? If the dye is oil soluble. If I am using a dye, water soluble dye, and if I am putting it in the emulsion and I see color change, that means I can understand my outer phase of the emulsion is water. Water is the outside. So this is a oil in water emulsion. This is called dye test. Same another test is there, that is called a filter paper test. Filter paper, you know, right? You have used multiple times on filter paper. So if I am putting a drop over here, one drop of emulsion, and if it is water loving, outer phase is water, what will happen? It will spread out, right? It will spread. Because outer phase is water. And water, normally our filter paper is hydrophilic, right? They like water, they love water. So if the drop is spreading, that means the outer phase of the emulsion is also water. And in the sense, I can say my emulsion is oil in water. Emulsion. This is for a hydrophilic filter paper. Nowadays, we can also have nylon membrane, polystyrene membrane, those kind of filter paper is also there. And I can test for other emulsion type also. Water in oil emulsion also you can test if the surface is hydrophobic surface. Okay, if the filter paper is not made up of cellulose, but it is hydrophobic, maybe polystyrene, polyethylene based membrane kind of things, I can do the same test here also. So basically, when I talk about filter paper, I refer only this Whitman or Whitman filter paper of which is water loving, that kind normally we refer. But nowadays, these varieties are also possible to identify. Same way, the last part of this discussion is conductivity test. Sorry, the last test for emulsion type identification is conductivity. You know, emulsion is a preparation containing oil phase and water phase. So these are the oils, but outside phase is water. So if I put some electrode here, positive and negative, and for example, we are passing some connecting, and we are going to measure what is the current flow through this route. You know that water is there, and definitely it will be not pure water, like salt is there. So it will be conducting electricity if the outer phase is water. If this is water, it will conduct electricity. But if it is oil phase, outer phase is oil and only water droplets are there, the opposite case. If the droplet is actually water, but outer phase is oil, then there will be no conductance, or maybe very less amount of conductance will be there in this case. So conductivity of a solution can also be used for quick assessments what kind of emulsion formulation we are talking about. The same thing has been discussed in the text. You may please go through. Oil or water miscibility, as I am telling, if it is mixing with something, filter paper test, we are putting a few drops, right? If it is in oil in water emulsion, then water tends to spread through the filter paper. Okay, that is the only point, filter paper test. Conductivity measurement is also in the same principle. If I am having more conductivity, then I can understand this outer phase is water, so it is actually water in oil emulsion. But if it is oil in water emulsion, I will not find any conductivity over there. Dye solubility test, as I was telling, if I'm putting some dye, how is it going to be soluble, colored background, or it is non-colored background. So this will actually tell us what kind of emulsion we can find. Similarly, other properties are also there. Droplet size distribution. We can also use photographies for emulsion preparation. We can also get for imaging microscopy techniques. These can actually talk about, or light scattering can be also used to identify what is the size of the emulsion droplet, or emulsion droplet distribution can also be used for quality testing. Next class, possibly we will discuss about emulsion stability, and not stability, rather we will talk about instability of the emulsion in our next class. I will stop this discussion here. Please go through these 3 chapters for your exam point of view, exam perspective, that I will just highlighted. First one is this emulsion. We'll be talking about emulsion and creams. That is chapter number 27 we are going through. Then we talked about capsules, chapter number 33 and 34, and parenteral drug delivery, 36. So 33, 34, 36, and 27. These 4 chapters, not everything, whatever you are discussing in this class, you may please go through and focus for your second internal exam. I think I will close it now because we are having a meeting now. Any questions if you have, you can ask me. Already 4 people have left. If there is no questions further, I think we can leave this class.
Thank you, sir.
Thank you all.